Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary LaRude. Two special guests today, Eric Leclerc from UMS and David Vai from AWR. So we're here at European Microwave Week 2019 in Paris, and it's been a great show. I think the attendance has reached the record levels that it did last year, and the exhibition has set a new record. So it was a good show so far. A lot going on in the conference. I had the time to visit some of the test and measurement companies, and Keysight is showing 110 gigahertz scope now integrated into their 5G test setup, and you can actually, just focus on the frequencies of interest within that 110 gigahertz range. And then I've seen some very mature 5G OTA testing setups from NI. They have now a chamber that they're offering with their setup, and we also have the same thing that was also available from Rohde & Schwarz. They've been doing a compact range setup for many years now. So the 5G OTA testing is becoming more mature, and I think that's a good thing for us. I also saw Anritsu had a 220 gigahertz VNA offering now, so that's a very high frequency. And we saw Copper Mountain come in with their Compass technology setup that they're able to characterize materials over various frequencies. So a very good offering from the test and measurement companies. How about the semiconductor companies?
Well, before we talk about that, one of the things I wanted to mention, a lot of activity in cable assemblies and waveguide, which we tend to think of as pretty mature and not a lot of development. But particularly for the satellite applications, the low Earth orbit, a number of companies like Huber and Sooner are developing cable assemblies with connectors that can't come out with vibration. And now Huber Sooner is applying that to more of the industrial market. And we're seeing, because of the millimeter wave interest, a lot of activity with waveguide to coax type adapters. So a lot of activity there. On the semiconductor side, one of the interesting things, we had a celebration yesterday. WIN Semiconductors celebrated their 20th anniversary. It's amazing to see the evolution of the market in that time. We're seeing a lot of interest in GaN. You've announced a GaN process, 0.15 GaN process. There's also Wolfspeed has qualified and released their process as well. And I think this open foundry activity with a lot of companies is causing some startup companies like Altum RF and others to have a real place in the market to come in for product development. So we're seeing this trend, and it's a good one, I think, for the industry.
And you guys have had a great collaboration together. You did our July cover story about the partnership in characterizing some new GaN processes, developing those models, and the verification of those processes. Can you give us a little overview of that partnership and how it worked?
Thank you, Pat. Yes, it's true that we are collaborating with Microwave Office people and National Instrument AWR from a long time now, in order to make available all our PDKs from the different gas and GaN processes for Microwave Office. So, for example, very recently we will introduce the GH15 PDK, which is unique PDK, including nonlinear model, noise model, the diode model, series and parallel switches. The partnership with National Instrument AWR is working for a long time now, and we build a solution because our models in UMS are built internally on our own tools, and so we need a step between the model preparation and the PDK release. We need a step to introduce the model with the support of the R&D and support engineer from National Instruments in the Microwave Office tool. And for that, so we deduce from the equations. The nonlinear model, you can imagine, are a bit complex because now we have electrothermal models which also take into account not only the temperature but also the traps effects. So the models are becoming more and more complex, which means that the validation process has to be very robust. And for that, we compare not only simulations from Microwave Office to other tools, but we also compare the measurement results we got by S parameter measurement, non-linear measurements. For example, for power, we perform load pool simulations and we compare the load pool optimization obtained by simulation with the measurement results. This is a way we traditionally do that, and for the other element as passive devices, it's, I would say, more simple process, but it's the way we do that with AWR people.
And I might add to what Eric said. We host a design forum, a power amplifier design forum at European Microwave Week. This is our sixth year presenting that, and we frequently. Dr. Steve Cripps is the keynote speaker. If anyone is doing PA design, they're very familiar with his work, especially in the area of load pull simulation analysis and how you use that to design waveform engineering. And so I sat through that, and I actually presented at that forum yesterday, as Eric did as well. And what really struck me is how important the model is to the PA design, especially these more sophisticated architectures that are coming out. All different variations on Doherty PAs, and Dr. Cripps got into the techniques that the people are looking at with digital modulation, and really looking at this combination of analog and digital is really going to be driving future PAs. And I think all of that is really predicated on excellent modeling. And so I know that the UMS team has really, in addition to working on the GaN technology itself, is all the effort that's gone into the electrothermal model and to model the traps. And without that, people are really not going to be able to design the next generation of power amps. And it's very exciting what's happening. And we're very happy to be a partner with UMS on this effort.
So you talked about the importance of modeling. Can you talk a little bit more about how you have confirmed the simulations and the models, and how you give designers confidence that when they design with these, they're going to get a good result?
I think first it starts with a deep characterization of the device. So not only S parameter, but also we perform pulsed S parameter measurements. We performed load pull measurements, and the load pull for power, or load pull for power added efficiency, is used to validate the behavior of the model. So the models are taking into account all the non-linearity of the devices. We took also into account all the parasitics elements, and finally, I would say at the last step of the validation process, we ask a designer to experience the model, to do a preliminary design. And generally speaking, especially for a wideband amplifier, when we have the good shape for the gain, when we have the gain flatness, the right and proper gain decrease at the edge of the band, it means the models are good. Especially, I would say, another topic today which is important is about linearity. Because, for GaN, for example, for 5G, we need to combine high performance and high power added efficiency with high linearity. This is also very challenging compared to the past story with gas, where you need only power and that's it. Here we need, for example, with Doherty, we need to work with some back off in order to keep at the same time good linearity and good power added efficiency. And it's also a way to show that the quality of the model, to show that the model is able, of course, to calculate the appropriate output power, but also the power added efficiency. And for that, you need to have the right variation of, for example, the drain current versus the input power, calculate appropriately the power added efficiency, and finally also the good linearity. In some case, for some telecom product, we have to perform very complex modulation scheme calculations. So for 256 QM modulation, for example, and to show that even with these complex modulation schemes, which takes into account some dynamics effect, we got a good simulations, which means also our designers and our customers using our process in foundry mode are able to use our nonlinear model not only for PA optimization, but also for, I would say, linearity optimization. So, for example, we did comparison of PAs for telecom with or without a digital predistortion system, and we can say that even without the digital predistortion system, we got good results from a linearity point of view through the quality of the nonlinear model we provide.
And so can you just give us some highlights of that new process, the 0.15 micron process, about what it can achieve?
Yeah, definitely. So it's true that we released 2 days ago for the show the opening of the GH15 process, which is a 0.15 micrometer GaN on SiC process. So this process will cover application from and allows power from 20 to 35, 38 gigs. Typically with a cutoff frequency of 50 gigs, which means we can use this process at 20 volt, and which provide about 3.5 watts per millimeter, with typically 40% power added efficiency at 30 gigs. So we expect a lot from this process, and we have a lot of customers who are ready now to jump on that process for some applications like K-band VSAT. There are a lot of requests for product from few watts to 20 watts, let's say. But in addition to that, I would say that not only for high frequency, below 20 gigs, we also have GH25, but with the GH15, we get better gain, so better gain flatness for wideband, for example, and we are going to release a new wideband amplifier with this process. It could be also better power added efficiency. So 2 days ago, for example, we present K-band 10 watt PA for satellite communication, so very high throughput satellite communication. It's so for a space customer, Thales, in fact. And so what is amazing with this product is that due to size request, we embedded the power amplifier in a metal ceramic package for hermeticity, which combine and which integrates the antenna inside the metal ceramic package. So this is today unique, and this again is an example of circuit which requires a lot of, I call that multi-layer simulation. So because it requires thermal simulations, EM simulations, electrical nonlinear simulations, and also in some case for packaging mechanical simulations. So it's complex story. So this is now able through the opening of the GH15 process.
If I could just add to what Eric said, I don't know if you've had a chance to go see Oralis, who's at the show. We just are doing a success story with them. They're a customer of AWR. It's a K-band satellite chipset that they've done on the UMS process. They did the package modeling in our 3D FEM tool analyst, but the process, the design kits were on the GH25 process. You mentioned, SATCOM application, and here's a working one. It's a very interesting chipset. The proof is in the pudding. Customer Oralis has a great demonstration chipset they designed with this process. So if people haven't seen that before, I recommend they check that out as a proof of what UMS's technology is capable of doing.
Well, congratulations on the new process release. It sounds like the collaboration with NI AWR will give designers a lot more chance of first pass success. And we want to thank you both, Eric and David, for coming in. And we're here at the European Microwave Week on our final Thursday of the exhibition. And we hope that if you're at the show, you've enjoyed the show. And if not, you'll check out all the activity on Microwave Journal to see the coverage of the show. Until next time.